No matter how old they are, everyone must watch out for their health. While playing sports, taking walks, or even jogging would be good for you, at my age, I have to watch out for what I eat. And since I have a sweet tooth, sugar is something I must avoid. Also, no matter how much sugar I would like to add to my drink, after a point, sugar crystals just won't dissolve. Is this nature's way of stopping me from having too much sugar, or is there chemistry behind it? Keep thinking. Hello and welcome to our show on the dynamic nature of equilibrium. Dynamic means active and equilibrium means balance. And there are innumerable systems in this universe that require active balancing and therefore exist in the state of dynamic equilibrium. So let's try and understand this concept better. In this episode, we will understand the meaning of dynamic nature of equilibrium, apply the concept of equilibrium to chemical and physical processes. We will also define what are reversible reactions and find out how you can increase your scores in your exams in Exam Decoded. Let us begin this session by defining equilibrium. Equilibrium is a general term which applies to both chemical reactions as well as to physical changes. It is the stage of a process in which properties like temperature, pressure, and concentration of the system do not show any change with the passage of time. Now, you must note that in every process that attains equilibrium, two opposing processes are involved. And equilibrium is attained when the rates of the two opposing processes become equal. If these opposing forces involve only physical changes, the equilibrium is called physical equilibrium, and if the opposing processes involve chemical changes, that is, the opposing processes are chemical reactions, the equilibrium is called chemical equilibrium. It is said that the best way of learning chemistry is by experience and experiments. So why don't we experience firsthand some physical processes in equilibrium with a visit to the lab? For this, put 2 grams of solid iodine in a closed vessel and keep it for some time. After a while, the vessel will fill with violet vapors and the intensity of the color will also start increasing. However, at a certain point in time, you will observe that the intensity of the color will become constant. This is the stage of equilibrium in which solid iodine sublimes to give iodine vapors and these iodine vapors condense to give solid iodine. This kind of equilibrium is called solid vapor equilibrium and is an example of equilibrium in physical process. Just as there is solid vapor equilibrium, there also exists liquid vapor equilibrium. And once again, we shall look at an experiment to confirm the theory. If we put petrol in an open container, it will get completely vaporized. But if we put petrol in a closed container, petrol vapors are formed. The level of liquid petrol will first decrease and then become constant. This is known as a stage of equilibrium. At this stage, rate of evaporation becomes equal to the rate of condensation. This shows another characteristic feature of equilibrium in physical processes, which is that it can only be attained in a closed system at a given temperature. Let us now go back to the sugar solution I had made at the beginning of the show. What was happening there? After a point, the solution became saturated with sugar and hence no more sugar could be dissolved in it. This is a stage of equilibrium. Here, the molecules of sugar from the surface of the undissolved sugar going into the solution is the same as the number of molecules of sugar being deposited back on the surface of undissolved sugar. So, the amount of undissolved sugar and the concentration of sugar of the solution remains constant. That is, the rate of dissolution becomes equal to the rate of precipitation. All the processes that we have just discussed exhibit the dynamic nature of equilibrium. Scientifically speaking, equilibrium is dynamic because both the opposing processes occur at the same rate and there is a dynamic but stable condition. If you recollect, I had told you at the beginning of the session that the dynamic nature of equilibrium occurs in both physical and chemical processes. So what is chemical equilibrium? Chemical reactions reach a state of dynamic equilibrium when the rate of forward reaction becomes equal to the rate of backward reaction. For a better understanding, let us consider a reaction known as a reversible reaction. A reversible reaction is one in which the reactants react to form products under certain conditions, and the products can also react to form the reactants under the same conditions. In other words, a reversible reaction is one which takes place not only in the forward direction but also in the backward direction under the same conditions. After discussing reversible reactions, natural question in your mind would be, what are irreversible reactions? It is really quite simple. If a reaction cannot take place in the reverse direction, that is, the products formed do not react to give back the reactants under the same conditions, the reactions are called irreversible reactions. Going back to our discussion on equilibrium in chemical processes in reversible reactions, let us consider the example of a chemical reaction between gaseous hydrogen and iodine carried out in a steel vessel to form hydrogen iodide. Here, hydrogen and iodine react to give hydrogen iodide as the forward reaction, and hydrogen iodide gives hydrogen and iodine as the reverse reaction. In the beginning, the concentration of H2 and I2 are maximum and the concentration of HI is 0. As the reaction proceeds, the concentration of H2 and I2 start decreasing and the concentration of HI starts increasing. Therefore, the rate of forward reaction decreases and the rate of backward reaction increases. At one point, the rate of forward reaction becomes equal to the rate of backward reaction and the reaction reaches what is known as a state of chemical equilibrium. At equilibrium, the concentration of each of the reactants and the products becomes constant. Also, since at equilibrium, the rate of forward reaction is equal to the rate of backward reaction, the equilibrium is dynamic in nature. Generally speaking too, in case of a reversible reaction between reactants A and B forming products C and D, a stage of equilibrium is reached when the concentration of each of the reactants and the products become constant. That is, the rate of forward reaction becomes equal to the rate of backward reaction. I am sure by now you are quite clear about the concept of a reversible reaction. So will you be able to apply it? Let's test you on that. You have to tell me, is Haber's process a reversible or an irreversible reaction? I expect you to know the answer because we have learnt about the Haber's process in great detail in previous sessions. Need some time to refresh your memory? Well, then let's take a short break and regroup for the answer and much more after this breather. Welcome to the show once again. And the question I had left you with before the break was, is Haber's process a reversible or an irreversible reaction? And the answer is, Haber's process is a reversible reaction. In case you are still wondering about where you had studied about it, Haber's process is used for commercial preparation of ammonia gas from nitrogen and hydrogen. In fact, Haber's process is very good example of chemical equilibrium at work, and you can even state this in your exams. A chemical equilibrium can be established only if none of the products are allowed to escape or separate out as solids. This is because if any product is allowed to escape, then the reaction will no longer remain reversible, and a chemical equilibrium has meaning only for a reversible reaction. For example, in the reaction of heating of calcium carbonate to give calcium oxide and carbon dioxide, if carbon dioxide gas is allowed to escape, the reaction will no longer remain a reversible reaction. Similarly, a reaction is irreversible if one of the products separates out as solid. Another important characteristic of chemical equilibrium is that it can be attained from either direction, that is, from the direction of the reactants as well as from the direction of the products. This can be understood with this experiment. Take two identical glass bulbs in which the glass bulb label A contains mostly N2O4 gas, which is colorless and is placed in ice. The second bulb B should contain NO2, which is reddish brown gas and is kept in boiling water. At 98 Kelvin, the color of glass bulb A deepens and the color of the glass bulb B fades away. This is because while N2O4 is being converted into NO2, the vice versa is also happening simultaneously. Ultimately, the color in two bulbs become identical and thereafter no further color change occurs. This shows that a state of equilibrium has been reached in both the bulbs and also that equilibrium can be reached from either side. It is time to shake you out of your equilibrium, and for that we have a caller with a question.
Why does a forward reaction slow down and a reverse reaction accelerate in a reversible reaction?
The answer to this is that as a reaction proceeds, the reactants are used up, and as a result, the forward reaction slows down. Also, as more of the products are formed, the reverse reaction accelerates. Quite easy, wasn't that? Well, I hope you have been attentive so far, because I am soon going to put your knowledge to test in the next segment. That's right, coming up next is Exam Decoded. So, stay tuned. Welcome back to the show. Let's look at what we have discussed so far on the dynamic nature of equilibrium before we proceed to Exam Decoded. In today's episode, we have learned that equilibrium is the state of a process in which properties like temperature, pressure, concentration of the system do not show any change with the passage of time. We also learned that dynamic equilibrium occurs when two opposing processes proceed at the same rate. Also, dynamic equilibrium occurs in both physical and chemical processes. And in a reaction, at equilibrium, the concentration of each of the reactants and the products become constant. And now, it's time for the most awaited section, Exam Decoded. Welcome to Exam Decoded, your personal guide to top scores, expert tips, and ideal answers to tricky questions. To begin with, there is the rapid fire round that will test your mettle in dynamic equilibrium with 5 questions of 1 mark each. You will get 5 seconds per question, and while answering, you must keep track of your scores as well, because at the end of the round, we shall tally your scores with the topper scorecard. So shall we begin? Here is my first question. Which of the following represents a reverse reaction in a reversible reaction? A. Complete reaction. B. Balanced reaction. C. Reactants forming products. D. Products forming reactants. And the answer is D, products forming reactants. Now the second question. Which of the following reactions reach equilibrium? A, reversible, B, irreversible, C, both A and B, D, none of the above. The answer is A, reversible reactions reach equilibrium. The third question is, a reaction is said to be in equilibrium when the rate of forward reaction is equal to the rate of backward reaction. Is it true or false? The correct answer is true. Moving on to the fourth question. At equilibrium, the concentration of reactant is equal to concentration of products. True or false? The answer is false. Here is the last question. Dynamic nature of equilibrium is shown by A, physical processes only, B, chemical reactions only, C, both of these, D, none of these. And the answer is C, both of these. And with that, we have come to the end of the rapid fire round. Let's see how you have performed today. If you have cracked the quiz and got 5 on 5, well done. You are the topper high flyer and can expect full marks in this topic even in your exams. Scores of 4 or 3 make you an achiever, which means that you just stay focused and brush up your fundamentals. Anything less than 3 makes you a learner. Normally, this would have been a cause of concern, but then you can easily become a high flyer by watching the show more attentively and by logging on to our website www.topperlearning.com for practice tests. Now, while preparing for your exams, you need to have a good idea of how important a unit is in terms of marks it carries. The topic, Nature of Dynamic Equilibrium, belongs to the unit equilibrium and has a weightage of 6 marks. That makes it critical from the exam point of view and means that you must allot it sufficient time in your timetable. Questions on nature of dynamic equilibrium will test your knowledgeability and will appear as short answer type questions of 1 or 2 marks. It is always a good idea to know how to answer a question in the ideal manner so that you get full marks. And since I want you to be the best in whatever you attempt, let me show you a question and the best way to answer it. This is a 2-part question with a mark each for the 2 parts. Part A, what is meant by the statement equilibrium is dynamic in nature? Part B, can equilibrium be achieved in open containers? To tackle the first part, write the statement equilibrium is dynamic in nature. Means that the reaction does not stop. Both the opposing processes occur at the same rate and there is a dynamic but stable condition. This much will fetch you 1 mark. For part B, state that equilibrium cannot be achieved in an open container. Writing this much will fetch you half a mark. Now state the reason for this, which is that in open containers, since the products might escape, there will not be enough substances to reform the reactants and so the reversible process will not take place. Writing the reason will fetch you another half a mark. It's time now to give you that extra edge with some tips from our exam expert. So pay attention.
In the topic dynamic nature of equilibrium, while preparing for your exams, students, you should know about dynamic nature of equilibrium. It is important to know the difference between dynamic and static equilibrium. Equilibrium is applied to both chemical and physical processes. Dynamic equilibrium in physical processes is achieved during phase transformation. It is also very important to know that in chemical processes at equilibrium, the concentration of reactants and products become constant and not equal. I am sure, students, if you remember these tips, you can score good marks in your exams.
It's time for me to go now, but before I leave, here is a piece of advice for you. Whenever you study and feel a little distracted, all you need to do is to remind yourself that there is no such thing as knowing enough. And unlike chemical equilibrium, your capacity to absorb knowledge is never going to be saturated. So keep practicing and keep scoring. See you next time.